Hello guys, welcome back to my channel. In my last video on factor formulas, we showed you how we derive all the factor formulas and how we came to this point. It is imperative that you watch that video because that will help you to understand what is going on here. So what I've done is to summarize the four factor formulas that you would have derived in the previous video. Now, what we want to actually do today is to actually apply it. So let me go down and show you a question. So it says, prove that the sine of A plus the sine of B over the cosine of A plus the cosine of B is equal to the tangent of A plus B over 2. All right. Now, how do I know I'm going to be using the factor formulas? Let us go back up and look at the factor formulas here. All right. So if you notice the left-hand side here, sine A plus sine B, it matches the factor formula. It's almost as if we are saying sine X plus what? Sine Y. So here we can go right ahead and take the left-hand side. So taking the left-hand side. All right. Now, if we go back up here, we were told that the sine, or we found out rather, that the sine of x plus y was equal to 2 times the sine of x plus y over 2 cosine of x minus y upon 2. So this would become 2 sine of a plus b upon 2 cosine of a minus b upon 2. And of course, the factor formulas are on the formula sheet. It's just for you to apply them. Now what about the cosine of x plus the cosine of y? And there we go. 2 cosine x plus y upon 2 cosine x minus y upon 2. So this, when we apply it to this particular scenario now, it's going to be all over 2 cosine a plus b over 2 cosine a minus b upon 2. Now we have factorized the expression, which means that we can reduce. So 2 takes out the 2. We have the cosine of a minus b upon 2, so that would take out that out of my denominator. Now when I break this down, I'm going to end up with the sine of a plus b upon 2, and all this goes over the cosine of a minus b upon 2. We know what happens when you have the sine over the cosine. Alright, that is going to give me, and this should be the cosine of a plus b, of course. Now this is going to break down to give me the tangent of a plus b upon 2, which is exactly what I wanted. Alright, so it was supposed to prove that this would have given me the tangent of a plus b upon 2. So now that my left hand side is equal to the right hand side, my proof is over. Now here's a second example. Prove that the sine of theta plus sine 2 theta plus sine 3 theta. So right away we notice that that left hand side does matches the factor formula. Is equal to sine 2 theta into 1 plus 2 cos theta. What we know for sure is that we are used to seeing two expressions, but now I have three. That is not a problem. We just have to use what we were used to. So I'm going to have to select 2 to factorize that of time. Now, bear in mind that when I'm factorizing, I'm going to have to add the angles and divide them by 2. And I'm going to have to subtract them and divide them by 2. So would I put sine theta plus sine 2 theta? No, because if I add theta plus 2 theta, I'm going to have 3 theta over 2, which I don't have any at all on my right hand side. In fact, since sine 2 theta is even a part of my right hand side, I would probably want to leave that alone. Alright? So probably I could go with grouping sine theta with sine 3 theta at first. Now, just let us try to see if we can recall what the factor formula for sine a plus b says. Now recall, it doesn't matter if we use a plus b, x plus y. That's sine a plus sine b is equal to 2 sine of a plus b upon 2 cosine a minus b upon 2. Now, if you want to avoid negatives, you could put a larger angle first, but it's still not a problem because this is going to lead us to something else as well. So when applied to these two terms that I would have chosen, it's going to be 2 sine theta plus 3 theta upon 2 cosine of theta minus 3 theta upon 2 plus the sine of 2 theta. All right, let's break this down. So this is going to give me 2 sine. Now when I add theta plus 3 theta, that is going to give me 4 theta upon 2 times the cosine of negative 2 theta upon 2 plus the sine of 2 theta. All right, let's break this down. So this now becomes 2 sine 2 theta cosine of negative theta plus sine 2 theta. Now, because the cosine is an even function, when I find the cosine of a negative angle, it is going to give me the same thing as the cosine of the positive angle, all right? And you can refer to the graph for that. So this is going to give me now 2 sine 2 theta cosine theta plus sine 2 theta. Now, just like how we normally apply our algebraic skills, notice that sine 2 theta is common, so I can factor that out. So I'm going to have a sine 2 theta, which is going to leave me with 2 cos theta plus 1, which is exactly what I want. So the left hand side is equal to the right hand side, and the proof is over.